The average global sea surface temperature has been consistently increasing since the 1900s. This increase in global sea surface temperature is due to the rise in carbon dioxide and greenhouse gases in the Earth's atmosphere due to human activities. The rise in carbon dioxide and greenhouse gases began during the Industrial Revolution. Pre-industrial carbon dioxide levels were lower than 200. Currently, carbon dioxide levels are up to 400 and are expected to increase if greenhouse gas emissions do not decrease. The Earth's average temperature increases as atmospheric carbon dioxide levels increase. This causes snow and ice to melt, lowering the Earth's albedo and the ocean's salinity. The increase in atmospheric carbon dioxide levels is causing the ocean to become a carbon sink and increases the ocean's temperature and pH. These drastic changes in the ocean alters many marine organisms' distribution ranges. Many mobile marine organisms are experiencing a distribution shift from southern regions to northern regions. These distribution shifts can be over 120 miles northward from their native northernmost distribution regions as a result of the rapid increase in sea temperatures and changes in freshwater inputs. The purpose of this video is to review how the black sea bass are responding to climate change and how their shifts in distribution are altering the commercial fisheries in North Carolina and New Jersey. Black sea bass are warm temperate migrating species that inhabit reefs and shipwrecks on the continental shelf. Their general distribution is along the coast of the Atlantic Ocean from Cape Cod, Massachusetts to Cape Canaveral, Florida. They avoid coastal waters in the winter by migrating to the outer continental shelf. The commercial fishery for black sea bass is managed in 3 different stocks. 2 are along the Atlantic Ocean, and the other is a subspecies that is managed in the Gulf of Mexico. The Virginian province stock is distributed between Virginia and Massachusetts. The Carolinian province is distributed between North Carolina and the east coast of Florida. The Caribbean province is distributed within the Gulf of Mexico. Black sea bass commercial fishery stocks are separated into different management units based on their mitochondrial DNA sequence. There is a slight difference between the Carolinian province stock and the Virginian province stock's DNA sequence. There is a significant difference between the Atlantic stock and the Gulf of Mexico stock DNA sequence. Black sea bass caught by commercial fisheries can be tested to see if New Jersey fishermen are catching black sea bass from the Carolinian province by testing the fish's mitochondrial DNA. This would ensure that New Jersey and North Carolina are only catching black sea bass that are within their region to prevent overharvesting. In New England, sea bass from the northernmost distribution range move offshore in autumn, where there is a decline in water temperature. When they begin to move southward, as far as Virginia, during the winter, when black sea bass populations from the Caribbean province, Carolinian province, and Virginian province intermix within the central areas. Black sea bass from the southern distribution range that inhabit Virginia move offshore in the spring and have the same general seasonal distribution patterns as the northern stock. Looking at the map of the central distributions, you can see that during the summer, the stock stays around the coastal areas with little movement occurring. Black sea bass are mainly a mid-Atlantic winter commercial fishery that are mostly caught using trawls, but can also be harvested using pots, hand lines, and gill nets. In New England, black sea bass are not a primary fishery. When they are caught in otter trawls, they occur as bycatch, but were landed by the fishery more than 50% of their trips. The variation in fishery results were due to changes in species distributions during seasonal changes in gear selectivity. Now that black sea bass populations are inhabiting more northern regions due to sea temperatures increasing, the commercial fisheries in New Jersey only have to lower the otter trawl to make black sea bass a primary fishery. Black sea bass commercial landings have been decreasing since 1987. Yet the demand for black sea bass has been increasing over the years, creating an interest in commercial production. Commercial production has not been very successful due to the limited seasonal availability and early larval mortality. A major concern that fishery managers have now that black sea bass are shifting their distribution into the Northeast is that their population will be harvested beyond sustainable levels. If New Jersey and North Carolina do not find an agreed upon sustainable quota. Black sea bass eggs are most successful at hatching at temperatures between 15 degrees Celsius and 27 degrees Celsius, and at a salinity around 20 parts per thousand. The black sea bass depend on temperatures greater than 18 degrees Celsius with salinity levels approaching full-strength seawater of 35 parts per thousand during their early life stages to survive. Their eggs cannot hatch below 12 degrees Celsius and no warmer than 20 degrees Celsius, or at a salinity of 0 to 5 parts per thousand. Larval mortality is increasing since sea temperatures are rising and the ocean salinity is decreasing due to human activities causing changes in the Earth's climate. Community-based resource management enhances the ability of coastal communities to adapt to environmental changes. Building networks by co-managing an ecosystem can increase its ability to cope with extreme climate changes, events, and increase ecological resistance to these climate change events. Co-management allows collective action from multiple stakeholders working together with government agencies to achieve the common goal of resource management by eliminating self-interest. Marine protected areas, or marine reserves, help protect fish stocks from collapsing by restricting human activity within the reserve boundaries. This is a tool used to help increase the maximum sustainable yield of a fishery. The issue with marine reserves is that they only protect migrating species when they are within the boundary of the reserve, so other measures are needed to protect these species in the other areas of their range. We need to lower our carbon dioxide level to 300 parts per million. This is an ideal level because it allows our Earth's diverse climates to remain stable, allowing many different species to thrive. By reaching 300 parts per million, black sea bass should not have to expand their distribution range further north to seek cooler waters outside of regulated or protected marine reserves.